In this illustration, we are going to discuss about a situation in which a swimmer motorboat following the lighthouse. Now, here we are given that there are two ports A and B on two banks of a river with line AB, which makes an angle 60 degree with a river current that is root 17 meters per second. And the distance between A and B is 1200 meters, and a lighthouse throws a light beam from port A to B. And a motorboat starts from one port to another such that it always follows the light beam. If boat reaches B and come back to A in 5 minutes, we are required to find the velocity of boat with respect to water. Let's first draw the situation and analyze it carefully. So if this is the river, from point A, light beam is thrown to another port B, which is at an angle 60 degree with the river current. We are also given with the river current a speed that is root 17. Say in this direction river current U is there. So to move along this path, the boat has to travel with some speed such that if this speed is V, then U is added to it, and finally the boat will move along this line. And say if boat velocity with respect to water is making an angle theta, then we can write the velocity of boat along path AB is, here we can calculate velocity of boat along path AB when it is going from A to B is equals to this U. So if this angle is theta, this is 60 degree, here we can see this velocity we can write as V cos theta plus U cos 60 degree. Similarly, when it returns, then a boat has to travel with the same speed V at an angle theta, but when the speed U is added to it, the resulting speed will be less compared to earlier because the river current component along the line BA will be subtracted from V cos theta. So here again we can write in return path BA, boat velocity along line BA is, here we can see velocity of boat along line BA in return path we can write as V cos theta minus U cos 60 degree. And we can also see as boat is not moving in direction normal to this line AB, the component of boat velocity with respect to water and river current in normal directions must be equal so that these will cancel out. So we can write in direction perpendicular to line AB, we use V sin theta is equals to U sin 60 degree. The value of U is root 17 sin 60 is root 3 by 2. This can be written as root 51 by 2. Say this is our equation 1. And we are also given that total time in going and coming back along line AB is 5 minutes. So we can write this distance we are given that it is 1200 meter. So we can write the time in going from A to B is 1200 divided by this V cos theta plus U is root 17 cos 60 is 1 by 2. So this root 17 by 2 plus the time in coming back is again 1200 divided by V cos theta minus root 17 by 2. And this equals to 5 minutes in seconds. This will be 300. So if we simplify this equation, this will be a quadratic in V cos theta. On simplifying, we are getting V square cos square theta minus 8V cos theta minus 17 by 4 is equals to 0. If we solve it for the value of V cos theta, here you can see V cos theta we are getting is minus of minus 8 is 8 plus minus root of B square is 64 minus plus 17 divided by 2. So the 64 plus 17 is 81. The root of 81 is 9. So here we can eliminate the negative sign because V cos theta cannot be negative. So it will be 17 by 2 if we take this as our equation 2. Then if we continue over here, we can see 1 by 2, if we divide these two equations, this will result the value of tan theta, which is root 51 by root 17, that is root of 3 by 17. This implies the angle theta at which the boat should head will be given as tan inverse of root of 3 by 17. And if this angle we use, then from equation 1, we can substitute and easily calculate the value of velocity, which is here root 51 by 2 upon sine theta. On simplifying, we'll get it root 85 meters per second. That is the final result of our problem.